Okay, so an ion. An ion is any atom that has a charge. But I really want to focus on what causes that charge. So an ion is any atom that has a different number of protons compared to electrons. And the reason this causes the charge is if you take an electron away, you're going to have a positively charged atom. If you add electrons, you're going to have a negatively charged atom. So let's talk about how ions are formed. Let's use two atoms that work together a lot. We have over here sodium, and so sodium has an atomic number of 11, which means it's going to have 11 electrons. And again, I like to use the Bohr's model. I think it's good visually. So here's 2 electrons on that first shell. 1, 2, 3, 4, 5, 6, 7, 8 electrons on the second shell. And then on the third shell, we have just 1 electron. And so sodium is going to want to have a full outer shell, a full valence shell. And it's going to be really hard to get 7 more electrons. So sodium's going to have a tendency to give away an electron. Now, over here on the periodic table, one of the halogens, we have chlorine. Chlorine has an atomic number of 17. And so let's draw chlorine. We have Cl. It has 2 electrons on its first shell, and 1, 2, 3, 4, 5, 6, 7, 8 electrons on its second shell, and 1, 2, 3, 4, 5, 6, 7 electrons on its last shell, so 7 valence electrons. So it only needs 1 more. So these two are going to pair up beautifully because sodium is going to be willing to give away an electron, and chlorine will gladly take it. And so when sodium gives away this last valence electron, what happens is now its valence electron shell has 8. Sodium is now full. But sodium, let me erase this. So sodium has a total of 11 protons, and now it has a total of 10 electrons because it gave one away. And so if you have 11 positives and 10 negatives, you're going to be positive 1. And so now we have a sodium ion. So it is a positive atom. And if we look over at chlorine, chlorine had 17, or still has 17 protons, and it had 17 electrons, but it just gained 1. So now it has 18 electrons. And so if you have 17 positives and 18 negatives, that makes you negative 1. And so now we have a negative chlorine ion. And this is how sodium and chlorine become ions. Now, this doesn't mean they have to hang out together. You know, sodium gave up its electron, chlorine gladly took it. They are now both ions because they have a different number of electrons and protons. They could easily go on their own way. But what ends up happening with ions is, because this sodium is positive 1 and this chlorine is negative 1, they end up sticking to each other. Remember that positives and negatives will be attracted and stick to each other. And so when sodium and chlorine stick together, we call that an ionic bond. And so remember that an ion and ionic bond are different. An ion is just talking about the atom. An ion is talking about an atom that is either positively or negatively charged because it either gave away an electron or it gained an electron. An ionic bond is when 2 ions stick together. And this ionic bond is kind of a weak bond. They're not sharing electrons, they're not stuck together in any way other than just this charge. And so we can break ionic bonds pretty easily. And so when sodium and chlorine come together, this is called sodium chloride. We also call this salt. And so regular table salt, sodium chloride, is stuck together with an ionic bond. But it's so easy to break, if you dump salt in water, then you're going to dissolve the salt, and so you're breaking that ionic bond. But the sodium and the chlorine, or the sodium and the chloride, they stay ions. Just because you separated them doesn't mean they gave back the electron, and so you'll still have ions, but you broke the ionic bond.